And here we are to the final freaking video from 1.4 of our text. Yeah, these first three sections, 1.1, 1.3, 1.4, they're beasts. There's just a lot of info. We're just getting all the vocabulary, we're learning our basics, we're getting our ABCs, we're getting our multiplication tables down, essentially, in order to be able to do, say, like an algebra class. So these are all just foundational, just used over and over things. And now we're going to move into a game for which a calculator maybe won't help you. This is kind of where you're going to find where you get stuck. And these problems stumped a lot of my students last semester. So let's get into it. And this is the game. Find two solutions of the following equations. Give your answers in degrees and radians. I'd say 3/4 of my class last semester got to this problem. I just had no freaking clue. Not even understanding, like, what's the question even asking? Like, two solutions? What do you mean two solutions? Well, look. And then we have to be able to start reading problems. I mean, like, I don't know what's going on. Let's start reading so we can figure it out. So we're like, all right, when you're finding a solution, wasn't it like before you get something like this, x squared minus 7 is equal to 9 or something? And you're like, hey, I got to go find two solutions. And you find out that x is equal to 4 and x is equal to -4. You know what I mean? That would be like two solutions. So you go solve for the variable, right? You go solve for the variable. Well, what's the variable? It's not the frickin' word. That'd be the same thing. Like you're trying to solve for cosine. That's the same thing as solving. I'm going to solve for the square root. Not of x, not of anything. I'm just going to solve for it. Cosine's a word. It's a function. It's like a root or a square or a cube. It's just a function. The only variable we have is theta. It's asking us, find the frickin' angle. And look. Give your answer in degrees and radians. Even more evidence saying, find two frickin' angles that makes cosine of that angle equal √2/2. By using, I don't know, coterminal, reference angle. I don't know. You tell me. So what we're going to try and find, first I'm going to do this in radians. We're going to go find theta in radians. We got to go find two of them. So let's go find two of them. We'll find both of them in radians. Once we're done, we'll convert it into degrees. And we can just go and use this table. Start off this way. If we don't, oh, look at that. We're going to do a third problem too. If we don't know this table, we don't know the reference angles, we can't solve anything else. So we start with our reference angle and we're like, all right, cool. We're talking about cosine and we're talking about √2/2. So what's that reference angle? Pi/4. Dope, we got one of our solutions. Savage, here we go, Pi/4. And I'm just gonna move it down here and say that, well, this theta, you could also call it 45 degrees. Cool, that's the same thing. That's one answer. That's not two answers. That's one answer. That's like saying, I need you to give me two different temperature readings. And you're like 32 degrees Fahrenheit and 0 degrees Celsius. And you're like, nah, two different ones. You're just speaking two different languages. It's the same damn thing. Yeah, so we need to find another one. That's just one solution. Now, the way we're going to find the other one is we go, well, wait a second. We're going to use reference angles in reverse. We already know the reference angle, essentially. Right, we're like alpha is equal to Pi/4. That's the reference angle. Now we just need to find another place. Now, we can cheat, quote unquote cheat, and just add 2 pi to Pi/4. We can get another answer. That'd be acceptable. But I'm wanting us to think this way. ASTC. Where's cosine positive? Where's cosine positive? Here and here. Cool. Well, we already got our Pi/4. From being up in the first quadrant. Well, let's go find an angle down in the fourth quadrant that has a reference angle of Pi/4. So it'll be like 1 Pi/4, 2 Pi/4, 3 Pi/4, 4 Pi/4, 5 Pi/4, 6 Pi/4, 7 Pi/4. Oh shit, 7 Pi/4 has a reference angle of Pi/4. And we could have also come back from 2 pi, right? Or, I mean, 8 Pi/4 and subtracted the Pi/4 and found out we would be at 7 Pi/4. So there's a solution. 7 Pi/4. And if you were to convert this, you would find out theta is equal to 315 degrees. Now there's two solutions. Now there's infinitely many answers. I could just keep going and going and going and give you all kinds of freaking answers and tell you, like, shit, if you spin around in a circle, end up back here, 9 Pi/4. That's just adding 2 pi to this. That's all that would be. It would just be like adding 2 pi to your original and finding something coterminal. There it is. You could just play this game infinitely many times. You could find infinitely many answers to this. We're just asking for 2. So there would be a sufficient answer. Let's go to this one. Sine of theta is equal to the negative root 3 over 2. So right away, we're like, wait a second. Whoa, whoa, whoa. Well, let's not get into this shit yet. We're like, ASTC. So sine is positive up here and here. We don't want that shit. We want it where it's negative. Sine's negative down in the 3rd and the 4th quadrant. So we know we want our answer to be here or here. But first, we got to go find that damn reference angle. Let's go figure out what reference angle we need to use, because we're going to set our stuff up. And we're going to be like, all right, let's go find these angles. This one and this one. What is it? What are they going to be with the reference angle that we find? All right. So what's our theta going to be? What's our theta? Let's go look. So we're like, all right, cool. Sine, and now don't stress about the negative right now. We already thought processed that shit out. So we're like sine 3 pi over 2. Go over here and we're like, oh, the angle is pi over 3 or 60 degrees. So we write that. We're like, okay, cool. We got this. We got a reference angle. It's pi over 3. So now we just have to find those angles down here that have this reference angle of pi over 3. Because there's 2 of them in between 0 and 2 pi, such that this is true. All right, well, what do we got? So I like to play this game from the start. And go, we're at 0, and go, there's 1 pi over 3. There's 2 pi's over 3. There's 3 pi's over 3, because that's pi. And then what's 1 more pi over 3? 4 pi over 3. If we added another pi over 3, what would we get? 5 pi over 3. There's our 2 answers. We spun around in the circle, we would get 6 pi over 3. 6 pi over 3. 2 pi over nothing, right? Because 6 divided by 3 is 2. So our 2 answers are 4 pi over 3 and 5 pi over 3. Both of those angles have a reference angle of pi over 3. Huh? Which gives you a root 3 over 2, but since we're down in the 3rd and the 4th quadrant, bam. So we're thinking backwards. We're going to have to start doing this. This is just kind of showing you, this is equal to 240. And this is equal to, what is that, 300? Sorry. So there's the degrees. But this is getting us ready for chapter 2. Actually, 1.7. 1.7 and chapter 2. All right, let's do our last one. Now we got to go find out where tangent of theta is equal to 0. Now, if you look back up at the table, I don't actually write down anything for tangent yet, because unless you're talking about it, I don't really care. I'm not too interested. And I know that as long as I know sine and cosine, there's no issues. So we go tangent 0 divided by 1 is 0. 1 divided by root 3 is 1 divided by root 3. Same thing divided by same thing is 1. Root 3 divided by 1 is root 3. And 1 divided by 0 is undefined. Yeah, you get that stuff. You get that for free. So on our problem, it's asking us to find 2 angles such that tangent of theta is equal to 0. So we got to go find the angle. All right. No big deal. We're like tangent 0. What's the angle? We go back over and we're like, oh shit, 0 radians is 0 degrees. Cool. Let's go plug it in. We got a freaking reference angle. Well, it's technically not a reference angle. Or 0 radians. So I'm going to write it in as radians. So tangent theta is equal to 0. Or let's write it in. Let's be proper about it. 0 degrees. Now let's go find the other reference angle. Where else is tangent of theta equal to 0? And that requires a little bit of thought. But if we know something about tangent, here's a little trick. Tangent repeats on itself every 180 degrees, or every pi. Tangent repeats on itself. And let me show you. Tangent goes positive in the first quadrant for tangent. And then it's negative. Then it's positive. Then it's negative. It actually just flip-flops. It starts its cycle all over again after pi. So whatever answer we get for tangent, if you get 0, all you have to do, you want another angle, just add pi to it. Or add 180 degrees. Little trick. I'll let you think on that one. Or we could say that theta is equal to 180 degrees. We'll talk more about what we call the period of our functions. That would have been in 1.2, but I'm going to put that into our graphing, which is next. I don't stress too much about graphing. Yeah, I don't need you to either. But we will have to learn a couple things, like basic shapes of these. But we'll talk about that when we get there. Thanks for hanging in there. I'll see you in graph.